Okay, so first thing you need to draw the new X and Y axis, okay, because it's being moved, right, to a new place. So for example, this red graph, your middle line, which is your X axis, new X. Okay, and then you need to draw the new y-axis. The y-axis is the tricky part, right? You need to decide whether the question wants a cosine or a sine, right? And whether it wants the reflection or it doesn't want the reflection. So there are a couple places, right? If it's a sine without reflection, okay, if it's sine without reflection, then you'll put it here. Right? You will put a y-axis over there. If it's a sine with a reflection, then you will need to put it here. Okay, so those two places are for the sine with the reflection and without the reflection. If it's a cosine without reflection, then you could put it here. Okay, if it's cosine with a reflection, and then it will be here. You can see they're all equally apart. Okay, so you need to know your sine graph, cosine graph, the basic one, the shape, right, to decide where to put it. Okay, and then once you got the new X and Y axis, then you can figure out the location of your origin. Okay, so origin will have 4 options. Okay, so you have either here 1, 2, 3, 4, right? 4 possible places. So some teacher, they just give you a graph on the test, ask you to just 1 question, right? But then you will have 4 answers because you could use either sine or cosine with reflection or without reflection. Okay, we did a couple questions up here like that. Okay, so make sure you review that. And then amplitude, right? You can either use the formula or read the graph. And then for getting the B is 2 pi divided by the period. And CD is just new origin. Okay, so I think the hardest part is to get the correct new origin. The rest is you just plug it in A, B, C, D. Okay, and it will be done. So I'll see how you guys did on your homework. Okay, and we'll know if you get it or not. There's one more question has to do with this. Okay, instead of giving you the graph, they give you points. But we'll come back to that later, okay, if we have the time today. Because today I want to focus on word problem. Okay, so now you know how to use the graph to get a function. Okay, we step one more step back. They will give you the words, okay, in words, the word problem, and then you use the word, try to find the graph, draw the graph, okay, and then from the graph, you can figure out the function, okay? So they don't give you the graph anymore, they give you descriptions, and the description is with a story behind it, okay? All right, so let's look at next page. Page 55, okay? So instead of telling you points, right, they tell you there's a bicycle, right? So from the description, you want to figure out what a graph should look like. Okay, so let's have Daniel, can you read the question down for us?
The pedals on a bicycle has a maximum height of 30 centimeters above the ground and a minimum distance of 5 centimeters above the ground. A person pedals at a constant speed of 25 cycles per minute. Find the period in seconds for this periodic function.
And part B?
And find the periodic function in terms of sine and cosine. that models the pedal starting at the highest point.
Okay, thank you. Okay, so even if you don't have a bike, you probably have seen a bike, right? There are two pedals on each side, and then you have to step on them, make circles motion, right? Circular motion to keep moving forward, right? So the pedals can go up and down. So that's why it tells you the maximum height, right? Maximum height. And then there's a minimum, okay, distance from the ground. Okay, it tells you the speed. Those are the three numbers that I give you. So before we begin, right, well, let's use this description and try to draw a graph that represents it, right? So because this is the first question, right? So I'll help you to get started. So so this one, the measurements has the height, right? Goes up and down, we call that the height. So that's like the y-axis, right? Because y goes up and down. And then the other one, because it mentioned about period, right? Speed is a number of cycles per minute. It mentioned about time, okay? And then in the question, it also mentioned about period in seconds, okay? So the graph will be relating the height of the pedal and the time of your pedaling, okay? So at different time, your pedal will be at different heights, okay? So it's connecting the time with the height, okay? So since the height has to be the y-axis, so we'll draw it like this. So use h to represent our height of the pedal. And then on the ground, that means the height will be 0. So this x-axis is the time, okay? The time of your pedaling. Okay, so for example, right, I put the 0, 0 there. 0 means at the beginning of the time, right, before you even started, at the starting of your pedal. And also the 0 represent it's on the ground, right? So you could have, if I put a 1 there, that means 1 meter above the ground. Any questions so far? Okay, so first, when you get a question, you need to figure out what are the two variables. Okay, so we can write it on the side. Okay, let h be the height of pedal above ground, above the ground, and t is the time in seconds. Okay, so when you're ready to start graphing, can you raise your hand? Okay, when you finish writing all these words down. Okay, and then let's picture the pedal, okay, what it looks like. The pedal is attached to the gears, right? The gear will turn, right? And then the gear will attach to the chain, right? So let's draw the gear. Of course, the gear cannot be on the ground, right? Okay, we'll just draw a circle, okay? Too difficult to draw all the teeth, okay. I will erase the number for now. Okay, we'll put the numbers in later. So here's the gear. Of course, it has the teeth. Right? And then from the gear, you have the pedal attached to it. Right, now you can step on. Okay, and then once you step on it, right, it will start to turn, right? The top gear, top pedal will go down. At the same time, your bottom gear will go up, right? And start making the up and down movements, right? So that's why it has to do with the sine or cosine graph. It's like a wave motion. Right, so based on the description, we have a maximum height of 30, right? So highest place is 30. So we put 30 at this place. And where is the lowest place, Waylon? What's the lowest value? I cannot hear you, Waylon. Is your mic turned on? Okay. All right. 5. Yeah, very good. Okay, so 5 centimeter above the ground, so I will call that 5. Okay, so other than highest and lowest, another important place to find out is the middle, right? Because the middle is the place we need to draw the middle line, right? The midline. So can you guys find the location of the midline? Okay, what's the number for the height of the center? Okay, once you got that number, please raise your hand. What is the height of the center? It didn't tell you in the problem, okay? So sometimes they give you highest, give you the lowest, then you need to find the middle by yourself. All right, so Lily, what number did you get for the center?
17.5.
Can you say that again?
17.5.
17.5. Okay, let me write that down. 17.5. How about Angela? What do you have?
I got the same thing, 17.5.
Okay, can you tell us how you got it? 17.5.
I did 30 minus 5, and then that's like 25, and then divided by 2. But then that's like between the 5 and 30. So then I added 5.
So 30 minus 5 is 25, and then 25 divided by 2 is what?
12.5.
12.5, and then what did you do?
And then I added 5 to it.
Okay, add a 5 to it. So 5 plus 12.5. Okay, equals 17.5. Okay. Yeah, so that works very good. Okay, so you find the total distance, that's 25. You cut it in half. Half of it is 12.5. So you can either add the 12.5 to the 5, or you can take 30, take away 12.5. But it takes us 3 steps, right? 1, 2, 3. Is there anyone did it a different way? Anyone? did it differently to figure out the middle point instead of taking 3 steps? Philip, what's the way you did it?
I just took the distance and divided by 2.
Distance divided by 2. What's the distance?
25.
And then divide by 2 will be 12.5, right?
Yeah.
Yeah, so 12.5, would that be the middle place?
Yeah.
Okay, 12.5 is the distance only, but we are talking about on the axis. Okay, so this part very important. The 12.5 is the distance from the middle to the lowest, but not the location, not the coordinate. Okay, so a lot of time we just divide it by 2, then think it's in the middle, but it's only talking about distance. So you can also think about this way. If we have, here is on the x-axis, okay, we have 10, we have, let's say 18, okay? What will be the middle location? Caleb? If we have 10 and 18 on both ends, where is the middle?
14.
14, okay. How do you find the 14 then?
10 minus 18 divided by 2.
You mean 18 minus 10?
Yeah.
Okay, 18 minus 10 divided by equals to 8. 8 divided by 2 is
4, and then
4.
add it to 10.
Yeah, and then you add it to 10. Okay. That give you 14. Okay, so this way is still doing 3 steps, right? Because we need to find the total distance, which is 8, cut in half, which is 4, and then add it to the 10. Anyone did it differently? No one? Okay, so there's one way you can figure it out with just one step. Okay, think about 18. Okay, I'm using this example. Okay, 18 is like the score on the test for your first test. Okay, and then the second test, you got 10. And you want to find the average of your marks. Okay, how do you normally find average of your mark? Chris?
Do you add them together and divide by the number of things?
Yes, okay. So first test, you have 18, second test, you have 10, right? So you get 2 tests. So we add them up, 18 plus 10, and then you divide it by the 2 tests. Then that will give you the average of the 2 tests. Average is like finding the middle, right? You got some higher, some lower. Where's the middle place? Okay, so you add them up, that will give you 28 divided by 2. See, we got 14. Okay, so of course, finding distance is not wrong, right? You get it right. Just we always look for a faster way, okay, to do it. Okay, so let's put that down, okay, on the side. All right, let me erase all these. Okay, so your middle point, your midpoint, you can find it like an average, okay? So this one, 17.5, okay? Can write it on the side, okay? Average. So you find you have one test, you got 5 out of 100, okay? And then the other test, you got 30, right? You want to find the average between the 2 tests. So 5 plus 30, 35. Divide by 2, give you 17.5. Okay, so that's gonna give you the middle number. All right, so that's important because we need that to draw the new x-axis. Okay, so now next thing. Okay, can we move on to the next part? Okay, can you raise your hand if you understand how to get average here? All right, so next thing we need to talk about is the time, right? So the person starts pedaling, right? Because in part B, it says the pedal starts at the highest point. Okay, I highlighted that sentence. So that means you start at 30, right? And then it goes down to 17.5. And then continue pedaling, right? We're talking about the highest pedal, okay? Just the position of the highest. And then goes down to 5, right? Of course, the pedal cannot hit the ground. Okay, make sure it's equally apart. And then continue go up, right? After it goes to the minimum and then go up to highest. Of course, after that, it will repeat the history, right? Go down and go up and go up. Okay, and then continue. And then your bicycle will be keep moving forward. So let's connect them, okay? Make sure you don't connect like a straight line. Not like that, okay? So you have to have the upper half open down, bottom half open up, open down, open up, open down. Okay, so the graph that I drew here is like 2 cycles, right? It makes 2 turns. The highest point goes down, goes back up to the same place, right? From the beginning to here, that will be called 1 cycle, right? 1 cycle. After that, it goes down and go back up again. That's another cycle. Okay, so in the question, it tells you that it pedals at a constant speed of 25 cycles per minute. Okay, so that's gonna help us to answer question A. It tells you it pedal 25 cycles per minute. Okay, so instead of using the word period, they use cycle. Okay, so that's the tricky part in the word problem. They don't use the word that we learn, right? You have to use, they replace it with some words that we use in daily life, right? So cycles means periods. So the pedal makes 25 periods every minute, okay? So we want to find the time for 1 cycle, okay? How much time does it make? How much time does it take to make 1 cycle, okay? You think about this one. If you have the answer, you can raise your hand. It's gonna be seconds, right? Because in 1 minute, it can circle 25 times. So how much time does it take for 1 cycle? Okay, please raise your hand if you found the answer. Okay, we are looking for how many seconds per cycle. Minute, 1 minute is like 60 seconds, right? 60 seconds. Okay, it takes 60 seconds to turn 25 times. So if you just turn one time, how many seconds? Okay, raise your hand if you have an answer for that. Okay, Nick, what's your answer?
I'm not sure.
Oh, well, you raise your hand. No?
No.
Okay. Chris?
Yeah.
Yeah, what's your answer? How much time does it take to pedal one circle? One cycle?
0.42 seconds.
0.42 second. So pretty fast. 0.42 second. So the way you can check if your answer makes sense, right, is to find out how much time it takes for 25 cycles, right? Because if you have 0.42 seconds for one cycle, we pedal 25 times. So 0.42 times 25, that should give us 1 minute, right? Because it tells you 25 cycles every minute. So 0.42 times 25, that's 10.5 seconds. That's too fast, right? Don't you think? You pedal 25 times in 10.5 seconds. Okay, 0.42 too fast. Jenny, what do you think? How many seconds for a cycle? 2.4. Okay, can you tell us how you got 2.4? Okay, so divide 60, she says divide 60 by 25. Okay, so let's think about how we can figure this out, okay, if it makes sense. So 2.4, right? 2.4 seconds for one circle, one cycle, right? And then you do 25 times. If you multiply, it should give you 60 seconds. Okay, so which is 1 minute. Okay, so this answer makes sense. But if you want to do it, right? How do you set it up so you can find it? You can use something you learn in grade 8. Okay, it's called a ratio or proportion. Okay, so you can set it up like this. You have 25 cycles per minute. Right, so you can write a ratio like that. It takes 60 seconds for 25 cycles. Right, and then now you're interested in X seconds for one cycle. Okay, So you set it up like that, and you will see what to do, right? You are looking for X. Okay, so you can see X over 1 is 60 over 25. So to find X, right, you can do cross multiply. 60 divided by 25, okay? So that's our period. Okay, so you answer for question A, okay? To find the period is 2.5 seconds. Okay, any questions? So once you have these 4 important numbers, okay, then you're ready to find out the equation, okay, the function. Maximum, minimum, the middle, and the period. That's all you need, okay? So 2.5 seconds is here. Sorry, not 2.5, 2.4. Okay, 2.4. Okay, so another cycle, right? It will become 4.8. So you have these equally divide size of space, right? Okay, so now we have the graph. And we want to find, we can move on to part B now, right? We want to find the sine function and the cosine function for this graph. So we have changed the story into your last lesson, right? Last time we learned about how do we go from the graph to the function. Okay, so just like in the homework, okay, this one, you can find the sine function and the cosine function. So for practice, right, I would like you to get 4 different ones, like in the homework, okay, just for this one. So first is the sine, okay? Without reflection and with reflection. All right, and then cosine. Without reflection, with reflection. Okay, so by looking at the graph, okay, please find out these 4 functions. Okay, you can raise your hand once you got all 4. And if you need any hints on how to get started, you can let me know, okay? And I can help you go through a few steps, okay? So remember to go over this summary, right? You have to draw your own new X and Y axis, get the new origin, and then find A, B, C, D, okay? When you choose the Y axis, pick the one that's closest to the original one, okay? Closest to the 0, 0. let's have somebody to draw the midline, okay? Where do you put the midline? Eric, can you draw the midline on the graph?
Maybe over here, like this. Oops.
Yeah, yeah, very good.
Sorry, I'm just making it a straighter line.
Okay. Oh, perfect. Okay. Yeah, so that pink line is your midline. Okay. Now draw over you. Okay, very good. Okay, so continue find O4. Okay, start with the sign. Okay, let's look at the first one. Okay, sign without reflection. So I would like to see where you put the y-axis. Okay, if it's sign without reflection. Okay, Sophie, where would you put the y-axis? Can you show it on the screen?
Yep, 1 second, let me get annotate.
Yeah. Also the green line there, right?
Yeah.
Okay.
It's a bit slanted, but it's okay.
Okay. Is there a closer option? Closer to the original y-axis? The one you got is not wrong, okay, but there's a closer choice.
Over here.
Yes, very good. Okay, so we'll pick that one, the one on the left. Okay. Yeah, we want to get as close as possible because that's what the answer key usually will be. Okay, so everyone please pay attention, right? So for the sign without reflection should be on the left side. Okay, y-axis should be on the left side. Okay, let me try to create some space. Okay. Okay. Okay, so you can extend. Right, extend to the left, your graph, you can extend it. Okay, so if you want a sign without reflection, then you could put it here. Okay. If you already finished all 4 equations, please raise your hand. Once you got the first one, the other one is pretty fast, okay? Because you only need to move your y-axis. It only difference is the A could be positive, could be negative, right? And then the value of the C will be a different place. Okay, so let's check. We need to know the amplitude, right? Okay, let's check the amplitude. By now you should have the amplitude as well. Okay, Marcus, do you have the amplitude?
No, I'm kind of confused.
Okay, you understand up to the graph, how we got it?
Yeah, I got the graph, but I don't know what to do after the graph.
Yeah, so after the graph, suppose like here we have 4 equations to find. We start with finding sign without reflection. Okay, so if it's a sign without reflection, where's the first point?
On the x-axis.
Yeah, okay, so it starts from 0, 0, right?
Yeah.
And then would it go up or down?
Down.
It should go up.
Up. Sorry.
Okay, without reflection. If there's a reflection, it should go down. Okay, so it go up and then go down, right? And then
then comes back up, like down again, and then back
down
up.
again and back up. Yeah, so this is the one we are looking for. Okay, so we go to the graph and then we see that, okay, we will need to start from this point. That's why the pink line is on the left side.
Okay.
Okay, because starting from there, the graph will go up, go down, go down, go up, right? The yellow part, that's the sign without reflection. You see that?
Yeah.
Okay, so after you figure out that's the part we want, then we need to get the amplitude. Do you know what that means, amplitude?
No.
Amplitude is, if you look at previous page, is the distance from the highest to the middle line. Okay, it's the A.
Okay.
Okay, highest to the middle or the lowest to the middle. Okay, so if you look at the picture here, what is the amplitude?
30 minus 17.5.
Yeah, very good.
12.5.
What's that?
12.5.
Yeah, 12.5. Okay, so that's one way to do it, right? If you have the graph, or you can take the highest minus the lowest and then divide it by 2. Okay, so that's also 12.5. Okay, anyone else finished all 4 yet? Should be done by now if you know how to do it. Next thing we need to know is the period, right? Period, we already found it, right? Period is 2.4. So using the period, we can find B, right? So if you look at the summary, right, to get a B is 2 pi divided by the period. All right, so Evan, what's B?
I'm a bit confused.
Hmm?
I'm confused how to find this one.
How to find B?
Yeah.
You know how we got the amplitude?
Yeah.
Okay, B, you look at the formula in the summary. What does it say? How to find B?
2 pi over the period.
Yeah. Do we know our period?
Yeah.
How long?
2.4.
Yeah. So B is,
2 pi over 2.4.
yeah, that's it. Okay. There's nothing tricky. You just follow what you learned last week. Okay. Yeah, don't think too hard. All right. So we found our A, we have our B, right? Now CD, right? CD is the origin. So if it's the first question, right? First part, sign without reflection, our origin is this one, right? The one on the left side. Okay, this one. You need to extend your axis, okay? Angela, do you have the CD for the first origin?
I got negative 0.6 and 17.5.
Yeah, very good. Okay, so the 0.6 is your size of space, right? 0.6 to 1.2, 1.8, and then 2.4, right? But we are using the one on the left, negative 0.6 and 17.5. So that's our CD. And we can write our equation now, right? But remember, do not write y, okay? We don't have y here, we have h instead, right? So h equals to A is 12.5, right? Because no reflection, okay? Just keep it positive. Sine, right? And then B is 2 pi over 2.4, right? And then, let me erase that. And then we have C. C is negative 0.6. So it'll be T minus negative 0.6, so plus 0.6. Okay, and then D is 17.5, so plus 17.5. Okay, so that's for our first answer. If there is no reflection for sine, we'll choose that origin. Okay, is there any part still confusing about the first answer? You can let me know, okay? If you understand the first one, you can figure out the other ones. Is there any number that you don't know why it's there? Okay, this is your chance, okay, to ask me. And then we need to move on to the one with reflection. Okay, so I'm gonna erase the axis. If you got all four, please raise your hand. So Evan, do you understand how to get the first answer now?
Yeah.
Yeah, okay. So can you tell me where do you put the y-axis for the second one? For sine with a reflection, where would you draw it? You can draw on the screen. Very good. Okay, good job. So sine with a reflection, you will put it here. Right, so we'll start from there, go down, go up, go down. Okay, so it's a sine graph, but it has a reflection. Okay, so because it has a reflection, you need to make sure your A, you need to add a negative sign. Okay, B will not change. Okay, and then after that, CZ, what's your answer in the bracket?
T.
T, yeah, and then?
T minus 0.6.
Yeah, very good. Continue. Outside.
The plus 17.5.
Yeah, plus 17.5. Very good. Okay. So the CD for the second equation is at 0.6, 17.5. Okay, so we are done with the sign. Okay, sign with the reflection, without reflection, and also with the reflection. Okay, so nothing, not too much change, right? You just make sure you flip the sign. Okay, for A. Okay, we'll go to cosine. Okay, if you are done, please raise your hand. Cosine, make sure you pick the closest one, okay? Closest to the original axis. Okay, we'll start with cosine without reflection. Okay, Eric, where would you draw it? Cosine without reflection.
It's just the point that's already on the y-axis.
Okay, yeah, so original place. So no change. So you will start from here. That's your origin. Okay, so Marcus, can you give it a try? What's the equation then for cosine? Can you tell us the origin then? What's the coordinate?
Original line.
You see where the pink big dot?
Oh, okay. 0.6
Where's that?
and 17.5.
Can you say one more time?
Is it 0.6 and 17.5?
0.6 and 17.5 will be over here, this one. That's 0.6, 17.5, but we're talking about the one on the left side. Yeah, circle, the pink dot.
0 and 30.
No, not that one. No, okay, let me erase all the circles, okay? This one, the one with the yellow.
0, 17.5.
Yeah, okay. Do you know why we picked that one?
No.
Because the cosine, we're looking for cosine graph. What does a cosine graph look like?
It just goes down and then up again.
It has to go down and then go down and then go
And,
up and go up, okay? It has to go down twice and then go up twice, right?
Yeah.
Okay, so the graph will, the part that where it looks like that was starting from here. Go down, go up, go up. So that's why it starts at 0, 17.5.
Okay.
Okay. So if our CD is 0 and 17.5, how do we write the function? Angela, for cosine without reflection, what's the function?
12.5 cosine bracket 2 pi over 2.4 bracket sorry wait, sorry, 2 pi over 2.4 t and then like close the bracket and then plus 17.5.
Yes, very good. Okay, because this one we have 0, right, for the c equal to 0. So you could write t minus 0, but t minus 0 is same as just writing t. Okay, so this one you just put a t on the side. Okay, let me rewrite it. So t, you could either write it on the side like that, okay, or you can put it on the top with the 2 pi, right? 2 pi t over 2.4 is the same thing. Okay, last part is we want to have cosine with a reflection. Cosine with a reflection, where should we put it? Okay, Philip, where do you put the axis? Cosine with a reflection. Please draw it on the screen.
Oh, 1 second.
Okay.
Hmm?
Where? Do you draw it?
Oh, wait, it's here. Wait, no. There we go. There.
Oh, okay, yeah, very good. Okay, cosine with the reflection, we'll put it there. So our big origin is right there, right? Cosine, if flip around, it will have to go up, up, down, down, right? Like that. Okay, so our CD is at a different place now. Okay, so what's the equation for this one? Caleb? Caleb, what's your function for this one?
Oh, h is equal to minus 12.5 cosine bracket minus pi over 2.4t plus
Minus.
17.5.
Yeah, minus. Can you say again? Cosine and then bracket. What's after that?
Minus 2 pi over 2.4t.
2.4t, like this?
Yeah, bracket plus 17.5.
Okay, your origin is it the same place as you see right now on the screen?
Yeah.
Origin is here, right? You see a yellow highlight?
Yeah.
What's the coordinate for that?
Um, 1.2 and 17.5.
Yeah, so you should use 1.2 for your C. 17.5 is your D.
Oh.
Okay. And the value for B is not negative. No negative. So let's try again, okay? So after cosine,
1.2. Oh yeah, cosine bracket 1.2 bracket
1.2. Where'd you get 1.2?
because of C.
Oh, but you have to tell me the B first.
Oh, the B.
Yeah.
2 pi over 2.4.
Yeah. And then bracket.
Get 1.2.
You have to start with T.
Oh, no, T. Yeah, T minus 1.2.
Yeah.
Bracket
Yeah.
17 plus 17.5.
Yeah. Okay. Good. Okay, so for a question like this, if you have the graph, okay, we don't use B for the negative. Okay, because we just make things simpler, right? You don't want to have reflection over y-axis. Just keep all the B positive. Right, so these are the four. This is like kind of like a review. Okay, if you have still having trouble here, that means you probably will have some trouble in the homework, right? Your previous homework. Okay, all we did is just added a story behind it, right? Using the pedal to show that, okay, it's going up and down, and you draw your own graph. But then after that is old stuff, okay? So this one is using the pedal. The next one has to do with the spring. Okay, spring, it also goes up and down. Okay, another example is like the Ferries wheel. Right, Ferries wheel is kind of like pedal, right? Goes around in circles. And then another one that's not what they use in science is the rise and fall of the water in the ocean, right? Because the ocean has tides. It's affected by the gravity, right, from the moon. So it also goes to highest and lowest, right, depending on the different time of the day, right? High tide, low tide. Okay, so if you are able to model the height of the tides, right, then you can use it to predict when will be the best time to go out, right, to sail, right? When's the safe time to come back, right? So those are some of the application, how math can be applied. So of course, right now you'll be wondering, why do we bother to find out the height of the pedal, right? So of course, you can use the same idea, apply it to many different places. We'll have a break, okay? And then we'll try a few more, okay? We probably will do the spring and also the Ferris wheel, all right? So let's come back at what? 10 after 11, okay? And if you still have questions about these questions, let me know, okay? I'll see you soon.